This is the part 1 lecture of the chapter Motion based on Karnataka TET syllabus. Hello everyone, welcome back to Unfog with Dr. Atahar Parveen. In this lecture, I am going to discuss motion based on Karnataka TET science syllabus. This chapter motion comes under physics portion for paper 2 of Karnataka TET examination. Please watch this just 10 minutes video so that your motion in a straight line concepts get clear. Then after that we can solve few more numericals based on this, and then we can also cover the rest of the concepts based on potential energy, kinetic energy and Newton's laws of motion. Physical quantities are those quantities that can be measured. The physical quantities which are expressed only in magnitude are called scalar quantities. Distance, speed and time are examples of scalar quantities and they cannot be easily plotted on a graph paper. The physical quantities which are expressed in magnitude as well as direction are called vector quantities and we represent them by an arrowhead. Quantities like displacement, velocity and acceleration fall in this category and they can be easily plotted in a graph paper. Suppose there are two ways from your home to school. One is longer and the other one is shorter. Let home be your initial and school be your final position. Then the shortest distance between the initial position and the final position is called displacement and is denoted by lowercase x. Velocity tells about how fast and in what direction the object is moving. It is change in displacement of a body over time. Velocity is denoted by lowercase v and its SI unit is meter per second. A body is said to have uniform velocity if it covers equal distances in equal intervals of time in a specified direction. In general, the moving bodies do not have a uniform velocity. For example, a car moving on a bumpy road does not have a uniform velocity. A car on the circular track will have variable velocity because its displacement keeps on changing with time. That is, if a body covers unequal displacements in equal intervals of time, then it is said to have variable velocity. Average velocity is the total distance travelled by the body in specific direction over total time taken. How quickly and in what direction the velocity changes is acceleration. It is denoted by lowercase a and is defined as rate of change of velocity of a body. Acceleration is what we commonly call as pickup of an vehicle. If the velocity of a body is increasing with respect to time, then acceleration is said to be positive, and if it is decreasing with respect to time, then it is said to be negative. The negative acceleration is sometimes called deceleration or retardation. Acceleration is equal to change in velocity of a body, but velocity is equal to displacement of an object over time. Therefore, acceleration is displacement of a body over square of time and its SI unit is meter per second square. When a body moves along a straight line path, its motion is said to be one-dimensional or rectilinear motion. It can be studied with help of displacement time graph, velocity time graph and acceleration versus time graph. In a displacement time graph, displacement is plotted on y-axis and time is plotted on x-axis. Displacement time graph is helpful in finding velocity of a body as slope of graph is equal to y-axis over x-axis, which is equal to displacement over time in this graph. When a displacement graph is parallel to time axis, it means that the body is not changing its position with respect to time or the body is stationary. When displacement time graph is a straight line but not parallel to time axis, that is, it starts from origin and moves away from time and displacement axis, the body is said to be moving with uniform velocity as it is covering equal distances in equal intervals of time. Since the graph is a straight line, Therefore, it means that the displacement of a body is proportional to time. Slope of the graph gives uniform velocity of the body, that is, velocity is equal to delta x over delta t, where delta x is the short distance and delta t is the short interval of time. Here in this graph, delta x is equal to 10 meters and delta t is equal to 2 seconds. Therefore, AB over AC will be equal to 10 meters over 2 seconds and the velocity will be equal to 5 meters per second. When a displacement time graph is a curve, the body is moving with variable velocity and hence has some acceleration. The slope of this graph gives instantaneous velocity, which is a velocity at that particular point. Now we know that slope is equal to y-axis over x-axis and this must be equal to displacement over time in this graph. We can have instantaneous velocity v is equal to bc over dc and this is equal to 8 minus 2 meters over 5 minus 2 seconds in this graph. This one will be equal to 6 meter upon 3 seconds and our instantaneous velocity is 2 meter per second in this graph. In velocity time graph, velocity is plotted on y-axis and time is plotted on x-axis. If velocity time graph is parallel to the time axis, then body is moving with uniform velocity, which means there is no change in velocity. Therefore, the slope is equal to 0. The slope of VT graph is equal to change in velocity upon time and this is acceleration. Therefore, acceleration is equal to 0 as slope is equal to 0. The area under the graph gives displacement of the body. Therefore, here displacement is equal to velocity into time, which is equal to side PS into side SR of a rectangle PQRS, and the displacement is equal to 20 meter per second into 4 seconds and this is equal to 80 meters. If velocity time graph is a straight line moving away from the velocity time axis, the body starts from rest and its velocity increases at uniform rate. Therefore, slope of AC will be equal to velocity upon time, that is equal to AB over BC in this graph, and this will be equal to 10 minus 0 meter per second as AB is equal to 10 minus 0 and time is equal to 5 seconds. And slope of velocity time graph gives acceleration. Therefore, acceleration will be equal to 2 meter per second square. Area under the graph gives displacement and here in this case it is a triangle ABC whose area is half into base into height. Therefore, displacement is equal to half into AB into BC, which is equal to half into 10 meter per second into 5 seconds, or the displacement is equal to 25 meters. If the body is initially not at rest, then we can have this type of VT graph. We can then easily find the slope. Here, slope of AC is equal to velocity upon time, which is equal to AB upon BC in this graph. And we have AB is equals to 25 minus 5 meter per second and BC is the time axis, which is 4 seconds. Therefore, we can have the slope of AC is equal to 20 meter per second by 4 seconds, but this is acceleration. Therefore, acceleration is 5 meter per second square. We need to find the area under the graph for displacement. Here it is a trapezium ECAD and therefore displacement is equal to half into CE plus AD into ED. And we can have displacement is equal to half into 5 plus 25 meter per second into 4 seconds and displacement in this graph is equal to 60 meters. If the velocity of a body does not change uniformly with respect to time, we can have a graph like this. It means that the body has variable velocity and variable acceleration. The slope of this velocity time curve at that point gives instantaneous acceleration, which is equal to delta V over delta T. In this type of a velocity time graph, displacement can be found by counting the number of squares and multiplying them with area of one square. Therefore, displacement is equal to 12 into 6 because we have 12 squares under this curve and area of one square is equal to 6 square meters. Therefore, we can have displacement is equal to 72 meters. The acceleration time graph is plotted with acceleration on y-axis and time on x-axis. If the body is moving with uniform velocity, then AB coincides with time axis. Therefore, acceleration of the body along the time axis is 0. If acceleration time graph is parallel to time axis, then acceleration does not change. That is, the body has uniform acceleration and variable velocity. The area of graph gives velocity and here it is a rectangle. Therefore, acceleration into time gives velocity and we can have velocity is equal to 24 meter per second. If acceleration time graph is moving away from time as well as acceleration axis, then the body is moving with variable velocity and variable acceleration. Here, area of graph is area of triangle which gives velocity of the body. Therefore, velocity is equal to half into AC into BC, which is equal to half into 4 seconds into 8 meter per second square, and the velocity in this graph is equal to 16 meter per second. The DIY question is, what type of motion does the body has along AOB in each of these displacement time graphs? Do answer this question in comment section. I would be very happy to know your answers. Now, after watching the animated video, many of your concepts must have got clear. Now we shall see what are the type of questions which I am expecting. Identify vector quantity in the following. Volume is a scalar, mass is a scalar, density is a scalar, momentum is equal to mass into velocity, isn't it? In that mass into velocity, mass is a scalar, but velocity is a vector, right? So you can analyze in this way and decide whether the given physical quantity is a scalar or a vector. So, because momentum is related with velocity directly, this will also have direction and magnitude and this will be a vector quantity. Now, I am expecting a question based on displacement this year. Okay, for example, this is one question. A sprinter completes a round on a circular path of circumference 400 meter. What is his displacement? Means a person is completing one circular path of circumference 400 meters. That means going through the circle, he has come back in his original position. So what will be the displacement? He will have traveled a certain distance, but displacement will be, of course, it will be 0 because the initial and final positions of that person are same. One more example. A body is moving along a circular path of radius r. What will be the displacement of the body when it completes half a revolution? So, half a revolution means he has traveled half circle. He has traveled half circle means if the radius of that circle is r, then the body's displacement will be 2r. Because he has traveled half circle means the displacement will be through the diameter from one point to the other point of the diameter, the opposite point. So, you have to take the displacement as 2r. Isn't it? So, here option B will be the right answer. Now, this question is a previous year question. This says that a cyclist moving on a circular track of radius 20 meter completes half a revolution in 20 seconds. Then the average velocity is. We have seen in the animated video, average velocity will be equal to displacement upon time taken. Displacement will be 2 times r, that is 2 into 20 meters, upon the time taken for that half revolution is 20 seconds. So, I will divide it by 20. So, my average velocity will be equal to 2 meter per second. Now, these are the three equations of motion. V is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square. Here, what will be u? It will be initial velocity of the body. V will be the final velocity of the body. A will be the acceleration of the body. T will be the time taken by the body in traveling certain distance. And S will be the distance traveled by the body. I am sure you remember these equations. Now, there is one more equation which I can call it as a trick.
it talks about retardation. What is retardation? The opposite of acceleration. Okay, so you can use this formula S is equal to ut minus half at square for retardation. But then this trick S is equal to u minus a by 2 into 2n minus 1 is for particular type of question where they are asking you the distance travelled in nth second. For example, if this type of question is asked, then you have to use this formula of retardation. I am expecting this type of a question this time. So the question is, the initial velocity of particle moving along a straight line is 10 meter per second and its retardation is 2 meter per second square. Displacement of the particle in 5th second of motion is. So in this scenario, you can use this formula. Just substitute the values of the given acceleration, initial velocity, the nth second, which is 5 here. Okay, substitute and find the displacement of the particle in that particular nth second. In this case, it will be 1 meter. Okay, moving on. These equations which I was talking about are the equations of motion if the body is traveling on land. Okay. Now, there are equations of motion for a body which is falling freely. Okay. You can relate them to these old equations. But only thing is that here in place of distance travelled S, you use the letter H, which is the height of the object. One more thing which you have to know is about period and frequency. Now, if there is a circular motion, we describe it with the time period, isn't it? That is denoted by capital T. This time period is the time for an object to complete one revolution. Now, what will be the distance travelled in one revolution? It will be the circumference of the circle, right? So, that circumference of the circle is equal to 2 pi r. That's why the time period will be equal to distance travelled by velocity, or time period will be equal to 2 pi r by velocity. And remember that frequency and time period relation. Frequency is equal to 1 upon time period, right? We were talking about this in the chapter sound. So, frequency will be equal to 1 upon t, or frequency will be equal to v by 2 pi r. So, these three formulas also you have to remember because they are asking questions based on this also. Now, this is a previous year question. They are asking that if a stone is thrown vertically upward from the top of a tower with a velocity of 5 meter per second, it reaches the ground after 8 seconds. Find the height of the tower. So, you can use our formula. H is equal to ut plus half gt square. Here, the initial velocity is 5 meter per second and time is 8 seconds. And g, acceleration due to gravity, you better take 10. You don't take 9.8. Okay, because you will have less time. So, don't get into trouble by using the decimal points. Wherever only required, if there is accuracy, if they are asking for 1 mark and if there is accuracy, then only you use 9.8 meter per second square. So, just to substitute the values and find the answer. Here I have substituted g as 9.8. Okay, you substitute g as 10 and let me know the answer in the comment section. This is another question based on the period of revolution of the particle along a circular path. They are asking that if the period of revolution of a particle along a circular path of radius 10 meter is 40 seconds, the displacement of the particle after 2.5 minutes from its starting point is. So, here they are using two concepts, the concept of displacement and the concept of period of revolution. Now, they have given time is equal to 2.5 minutes. That means 2 minutes and 30 seconds. Convert the 2 minutes also into seconds. That means you multiply 2 with 60 seconds and add it with 30 seconds. So, total time which is given in the question becomes 150 seconds. Now, you can find the number of rounds travelled by the body or that particle. For one round, they are telling 40 seconds. Then in 150 seconds, how many rounds it will have covered? You do it 150 upon 40. You get 3.75 rounds. So, imagine a circle. In that circle, if that body has started moving from position A, it has travelled 3.75 rounds, means 3 times it has come back to A and 4th time it has stopped till B, isn't it? And the radius is given, that is 10 meters. Now, what will be the displacement? Displacement will be the distance between A and B, because the initial position is A and the final position of the body is B. Now, just apply Pythagoras theorem because it will be a right angled triangle and find the value of AB. AB square will be equal to square root of AO square plus OB square. Here AO and OB both are radius of the circle. That will be 10 here. It will be 10 meters. Substitute the values and find the answer. At last you will get square root of 2 into 100. Square root of 100 is 10. Put the 10 outside. It will be 10 into root 2. Root 2 is 1.41. So multiply it, you get 14.14 meter. So here option B will be the right answer. Now let's talk about the time period of the pendulum. The time period of the pendulum, it will be equal to 2 pi into square root of L upon G. 2 pi is a constant, right? The value of pi will be 3.14 or 22 by 7. L will be the length of the string of the pendulum, okay? And G is acceleration due to gravity. Just keep this relation in mind. Let us not go into much of the details because we have less time. We are focusing only on important points. Now based on this, one question was asked. If the mass of a pendulum is doubled, then the time period is. So if you know this formula, you know that there is no mass here, right, in that relation. So if the mass of the pendulum is doubled or tripled or whatever it became, the time period of the pendulum will not change. It will remain the same. Okay, moving on. Now let us know about the concept of kinetic energy and potential energy. We know that the capacity to do work is called energy. This energy can be stored in different forms, isn't it? And it is one of the physical quantity of the body and it is proportional to mass of that body. We have two types of energies basically when we keep in mind about the movement of the body. When an object is at rest, the body will possess potential energy. When the body is moving or it is in motion, then that body will possess kinetic energy. The trick to remember is just the word kinetic. Kinetic means movement, right? So if the body is moving, then the energy possessed by that body is kinetic energy. And how are they related with mass and velocity and height and all that? Kinetic energy will be equal to half mv square. M is the mass of the body, v is the velocity with which the body is moving. And potential energy is equal to mgh, where m is the mass of the body, g is the acceleration due to gravity, and h is the height of the body. So with this height concept, what comes into your mind? Something should come into your mind that there is height involved in the body. That means maybe the body is either moving, falling freely, or it is going upwards. For example, if someone is throwing a ball from the terrace, it will have potential energy at its starting point. Or if someone is throwing ball from the land, then also it will have potential energy at the starting point. So wherever height is involved, there you will have potential energy. Now what are the differences between kinetic energy and potential energy? First point is that the kinetic energy, that only you can say that if the body is in motion, it will have kinetic energy. If the body is stationary or it is at rest, then the energy will be potential energy. Then one more thing is that the kinetic energy can be transferred from one body to another. Means if one body is moving, it will hit the another body. Then that kinetic energy can be transferred to that body. Potential energy, it can't be transferred because the body is not moving, right? Then third point is that it depends on only mass and velocity, the kinetic energy. That's why it is equal to half mv square. But in potential energy, it depends on three factors. What are they? Mass of the body, acceleration due to gravity, and height or distance traveled by the body. Example of kinetic energy, the best one is the flowing water. Okay. And for potential energy, if the water is present at the top of the hill, still it has not started flowing down, it is just present at the top of the hill, then it will have its potential energy. Now this kinetic energy, it is relative with respect to nature because it is moving, right? Now potential energy, it is non-relative with respect to nature because it is not moving, it is just stationary. The body is stationary, then only it will have potential energy. The potential energy of a body at a certain height depends on, of course, it is mass, acceleration due to gravity, and height. That's why here option D will be the right answer. One more example which I am expecting this time. Two bodies A and B of masses 10 kg and 20 kg respectively are at the same height above the ground. Which of the two has the greater potential energy? In the potential energy, it is relating to mass, right? It is directly proportional to mass. But they are telling that the height is same. And acceleration due to gravity will also not change. So what will be the answer for this? For both the bodies, gravity and height are same. So body with greater mass will have greater potential energy because it is directly proportional to mass. One more example. A body of mass 5 kg falls from a height of 10 meter to 4 meter. Calculate the loss in potential energy of the body. There are more likely chances that they may ask this type of a question as 1 mark question this year. Okay. So they are telling that one body is there, it is of 5 kg. It is falling from height of 10 meter to the height of 4 meter. It is not coming to the ground. It has fallen somewhere near 4 meter. Now you have to calculate the loss in potential energy. So what is the procedure? It is very simple. First you find, in first case, height is 10 meters. You find the potential energy mgh. You put all the values. 5 into 10 into 10. That will be 500 joules. In second case, h is 4 meters, right? So 5 into 4 into 10. That will be 200 joules. Now the question is you have to find the loss in potential energy. That means you have to subtract the potential energy in first case and the potential energy in the second case. So your option D, 300 joule will be the right answer. One more question. They have asked that the two bodies of equal weight are kept at heights of h and 1.5 h respectively. The ratio of their potential energy is. So we have to just take the ratio of 1 and 1.5 because mg will get cancelled. 1 by 1.5 can be written as 10 by 15 or you cancel it with 5, 5 2s are 5 3s are. Your answer will be 2:3. So the ratio of the potential energies will be 2:3. Now one more question. This is based on friction. Friction means certain opposing forces are there which are experienced by objects when they are moving against each other. This opposing force is known as friction. For example, if there is one box, if that box is put on the floor, that box is not moving. That means that there is a static friction between the box and the floor. Okay. And then if that box is moving, someone is pushing it. That means there is a sliding friction between the box and the floor. And if that box is of cylindrical type and if someone is rolling it, then there is a friction between the cylinder and the floor which is known as rolling friction. This friction has everything to do with the contact, the area. In first case, in static friction, the box is fully put on the floor, right? Entire of one of the face of the box is in contact with the floor. So here the static friction will be having more force. That's why it is not allowing the box to move. In second case, it is sliding. That means the contact has become little less, right? It is moving. So here the sliding friction will be little less. Rolling means it is the lessest area is in contact now. That's why rolling friction will have lesser value. So for this question, if you have to put it in the descending order, then starting friction will have more magnitude. Second will be sliding friction. Third will be rolling friction. Here what is important is the contact area between the two surfaces. Okay. If the contact area between the two surfaces is maximum, then it will be static friction. If it is little less than that of the static friction, then it will be sliding friction. Then if the contact area between two surfaces is the least, then it will be rolling friction. Okay.
Okay friends, I will stop the class here. Just for a quick summary, I have given the list of formula here. I have given three equations of motions. V is equals to U plus AT, V square is equals to U square plus 2AS and S is equals to half AT square. And another formula is our retardation trick where the nth second we can find the distance travelled by that particular body in the nth second, which is equal to U minus A upon 2 into 2n minus 1. And time period for the pendulum, that formula also I have given here.
T is equals to 2 pi root of L upon G, and the famous kinetic energy and potential energy formulas also I have given here. Kinetic energy is equals to half mv square, potential energy is equals to mgh. You can either note down these formulae in your list, or either you can take the screenshot and preserve it to learn in future. Okay, or best thing is that just to pause the video and just learn the equations now only. These formulae now only you can learn, because they are not new to us, right? We have read all this in our school and in our college. Only thing is we need some brush up. Okay, okay friends, I will stop the class here. I will take another part for this chapter, motion. In that second part, I will do Newton's laws of motion, and I will solve many multiple choice questions. Okay, it will be sort of like a worksheet. Those questions can be based on Newton's laws of motion also, and other parts of this chapter also. Okay friends, and before signing off, I want to remind you all, if you like my work, please do like to this video and all other videos. Please go and check out my channel. You will find many videos based on Karnataka TET, and also I am making videos on HSTR syllabus also. Okay, and like my videos, share my videos, and if you are new to the channel, please do subscribe to the channel. Okay, this is the one way you can support my work. And if you are expecting more and more videos, then you must share my videos with your friends and other Karnataka TET aspirants. Okay friends, meet you in the next lecture of this chapter, motion, based on Karnataka TET syllabus. Keep working hard. Thank you. Bye.